See how that works. Solve the following for x.
Oh, I hate it. I can't.
Actually, I'm sorry. That's the next problem. Have it equal to 1. Instead of 8.
No laughing.
So, first question. So who remembers this from the previous chapter? Are there any restrictions?
Yes.
Go.
-1
That's one of them.
and -0.
How would you write that? X.
-0. X equals -1. I mean, X does not equal -1.
Not equal to -1, and also
0.
x cannot be 0. Correct. This gives you x is not 0. This gives you x is not -1. Where do you go with this? How do you solve something like this?
I know.
Okay.
You figure out what X is.
Right. How?
And then you do 3 times X and then 2
Well, hold on,
times.
whoa, whoa, whoa.
I actually don't know.
How do you find x? That's the whole point.
You do the problem.
Yeah. That's let's stick to technique. So if I give you this on a task, where would you start, other than listing the
You
restrictions?
cross
Go.
multiple.
Get the
Right.
answer.
Oh,
I was
Your
about
turn.
to say to get the thingamabob equal to 0, so that's
Oh, get
wrong,
the answer
right?
equal to 0? That's not a bad idea. Eventually we might have to do that. We'll check and see if we can use algebra or not. If it works with algebra, then you can leave off getting equal to 0. But if we get done with this and there's x squareds or something, then yes, definitely we have to get it equal to 0. Question or an answer.
Would you do the thing where you do like on the top you do times x plus 1 and then times x, like for both sides?
In other words,
that's what I was gonna say.
find a common denominator. Is there one? Like, what is this, when you're trying to get, first of all, what denominator does this thing have?
1, 0, 1.
Raise your hand, please. Let me check. So this is over what? 1. Now, I'm looking for a common denominator that covers this, this, and this. So I'm gonna be asking a question, I'll point to something and I say, what is this missing? Does that make sense?
I
Andy,
know.
what is this missing? X plus 1, as long as you do it to both sides, top and bottom. Does that make sense? Mary, take over. What's this missing? Missing an x, as long as you do it to both sides. Jana, what's this missing?
X
Definitely. And something else.
plus 1, 0, 1.
Don't
-1.
just stab wildly in the dark.
I don't know.
Everything in the bottom has to be covered at least once. Eric, what's missing over here other than x?
1.
Definitely the 1, although that doesn't change anything. That's true. There's something this does not have yet. Okay. X plus 1, as long as you do it to both sides. Now, there are 2 methods for doing this. One is you just get a common denominator. Let's do that. That's how we set it up here. I will show you another method that I showed you on Friday, but let's just do this first. Right now, we've got common denominator of 1 and x plus 1. The 1 doesn't really do anything, but I'm just going to write it just so you know it's there. Can somebody help me out with the first fraction numerator? What should be up there? Jack. What is this really when you mush it together? What's the new top? Yes, 2x plus 2. How do you get that? Right, you distribute the 2 and you multiply it in. And while you're at it, what's this going to give you? 3x. Good. And Mio Galini, what's this gonna be? The one you can kind of ignore. Yeah, x squared plus 1x. Does that make sense so far? Now we can trot out the technique that I showed you on Friday. You can either common denominator this and add the like terms, or you can do something that's a little on the violent side, but cleans up the problem
Oh, I
quite
know.
neatly. Go.
You do like the multiply by like 10 or whatever, I forget what it's called. Like the machine
The
gun.
machine gun method. What are you gonna multiply by all of these pieces, in this case?
Oh me.
Yeah.
X plus 1.
Yeah, multiply by x and x plus 1. You can multiply by 1 too, but that's not gonna do much. So multiply everything by x and x plus 1 as long as you do it to
Both sides.
both sides. That's the only time you can do that. If there isn't another side, if there's no equals sign, you can't do that. If there's only one side, you can't do that trick. Because you gotta do it to both sides, and if it's not both sides, you're out of luck. So, as a matter of fact, actually, do me a yeah, go ahead. What would you get if you do that? Rob, take over. What happens here? What do you get? Or what happens?
2x plus 2 over 1.
Yeah, the x's cancel, the x plus 1's cancel. We're left with 2x plus 2 over 1. What does the over 1 do?
Nothing.
Nothing, so you can leave it. Plus.
And we have plus 3x.
Yes, and that's it.
And,
Because cancel, 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 cancel equals what?
x squared plus 1x.
Correct. Cancel, 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 cancel. Does everybody see how we get that? The first step was to get the common denominator and then multiply by the common denominator, which will massacre every fraction of the problem, which is nice. Bless you. Now,
Bless
question.
you.
Actually, let's go back to, let me see. Therese, could this be done with algebra? No, why not? Right, you've got regular x's and x squareds. If that's the case, if algebra is not eligible, what do we have to do? It was brought up about 3 minutes ago. Here. Well, I wish. You cannot use algebra. You get 2 different species of x. If you can't solve with algebra, then you must do something first. Go. Definitely you can do that. That's called simplifying. Go ahead and do that while you're at it. What do you get? Yeah.
What?
Go ahead and add those up.
5x plus 2.
Yeah, 5x plus 2. Any like terms over here?
No.
No, so just x squared plus 1x. So what does have to happen? Yeah. Fran.
The answer equals 0.
Get the answer equal to 0. If algebra doesn't work, you must get the answer equal to 0. No choice. If you want to use factoring, if you want to use complete the square, if you want to use quadratic formula, all of them need an answer of 0. How do you do that? Andy, take over. How do you get the answer down to 0? Yeah, and it's totally up to you whether you want to make the left-hand side 0 or the right-hand side 0. I really honestly don't care. You want to make the right-hand side 0?
Yeah.
Okay, so subtract x squared and subtract 1x. Okay, so subtract x squared, subtract 1x. What would you get?
Negative x squared plus 4x
Good.
plus 2 equals 0.
Equals 0. Good. Everybody right so far?
Mm-hmm.
Finish it off. What method do you want to use? Treska. You could if you're going to factor. Factoring is one of the methods, and it might work, it might not, I don't know. Yeah. Want to do quadratic formula?
Yes.
Totally up to you.
It's the best one.
Which, okay. It's sometimes the best. Complete the square. I will say, by the way, complete the square is usually one of the most annoying ways to do it, but it does have some uses, especially in algebra 2.
Could you just unfold?
Maybe. Let's try it. By the way, if we unfoiled it, you'd have to pull out a GCF of -1 first.
Yes.
just for giggles, let's try that. What do you have if you pull out a -1?
X squared plus negative 4x
Plus -2. Does this unfoil? Can you find two numbers that add up to -4 and multiply to be -2?
Uh, 2 and -2. I mean, -4 and 2. I actually don't know.
Okay. What do you think? I don't either. There's a reason why.
Because it doesn't work.
Doesn't work.
We
Yeah.
can magic pair it, right?
You can magic pair it. And I checked the magic pair, there is no magic pair.
Okay,
In other words, it's prime. By the way, good idea. If it's prime, you can't use factoring, but there are two other techniques that still work.
Yeah, I love these ones.
Quadratic formula.
Complete the square or quadratic formula. And let's do the quadratic
Leave
formula.
it,
Yes.
fine.
In order to use the quadratic formula, somebody has to give me A, B, and C. Actually, Rosie, go
I
ahead.
know.
-1 is A,
Uh-huh.
B is 4,
Four.
and C is 2.
Correct. So slam them in for me. Mary,
Mary.
what's the quadratic formula again? Before that? Right in front. X equals, good. Go ahead. There you go. X equals -b plus or minus square root of b squared minus 4ac all divided by 2a. Yes, ma'am.
When do we have to do that?
I think we have
Oh, you mean for extra credit?
2 weeks.
By the end of the quarter,
Oh,
which is
seriously?
about 2 weeks.
Memorized it yet?
But beware.
Oh, I said it.
Oh, yeah?
Yeah, I extended it because we kind of ran out of time. Everybody was going. And I was going. All right, look up here. Can somebody crank this through?
I can.
Go.
Okay,
What
so,
goes here?
4,
Yes, plus or minus the square root of
4,
4 squared minus 4 times,
-1,
yep, times
2,
2. All divided by 2.
-1.
Good. Simplify.
-4
Uh-huh.
plus or
Minus
minus the
square root of-
square root of, what is that? 64. 16.
16, good save.
Minus, 8. -8.
What's minus -8? By the way, that's correct.
-8.
What is 16 minus -8? What does that really mean?
8. I mean, 8, yeah,
Yeah,
8.
plus 8. All over what?
2, -2.
Take over, yeah, Jeffrey.
-4 plus or minus 24.
Uh-huh, all over. -2. Still with me? Rob, take over.
Yes.
Does anything reduce?
I don't know.
No, you leave it.
Does a radical,
Negative, wait, what?
does anything come out of the radical perfect square wise?
Radical 4 minus
Yep, radical 4 times radical what?
6,
So what is that really?
2 radical 6.
2 radical 6. Let's rewrite this. X equals -4 plus or minus 2 radical 6 over -2. How do you finish this problem? How do you simplify it completely?
I know.
I'm gonna give somebody else. Trust. You could GCF it. What's the GCF on top?
Oh, sorry. -2.
-2.
Parentheses 2 plus or minus radical 6.
Yeah, 2 plus or minus radical 6
And the
All-
-2's cancel.
and -2. Yes. When they're multiplied like this, you can do that. What's your final answer? X equals?
Oh, me?
Please.
2 plus or minus radical 6.
Got it. Those are your solutions. If you punch those into a calculator, you get some pretty disgusting decimals. But like one of them is like 4 or 5 point something, and the other one is, it's 4 point something, and the other one is a little bit negative, -0 point something. I don't know what they are, but you do not have to get decimals for those, just leave them as is. Questions? On your homework, it's probably gonna be nicer numbers than this, believe it or not. They'll probably be, half the time they'll be round numbers, half the time, well, almost half the time they'll be fractions. It's rare that you'll get something that looks like that. It's possible, but rare. So pretty much this means you put 2 plus or minus radical 6 here, and 2 plus or minus radical 6 here, which is interesting. But true. Questions? Double check. There were 2 values of x that were forbidden to us. Andy, which ones were they?
-1 and 0.
Yeah. Did we use those in our solutions? No. If this had come up with x equals blah, 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 and x equals 1, and x equals 0, we would have had to throw out the 0 and keep the others. These are the only ones that are forbidden. That's why we needed to do restrictions. Because if we come up with a solution saying, hey, this is the cure for everything, do you realize it kills people? I don't care, it's the cure for everything. It's going to make everybody die. No, but this is a great cure for everything. No, really, get rid of it now. It's about to explode. In other words, if something is forbidden, if it makes things explode, don't use it. Okay, even if it's tempting. Come on, everybody's doing it. Come on, here.
Someone just look at me.
How about-
You're,
what?
you're the one who do that, Brendan.
John says you.
Any questions?
Very nice.
Yeah, I know.
All right, open your books, please.
This is on, whatever it's
This is
called.
15B as in paper. Page,
I'm innocent.
the page, if you hadn't corrected the page is totally wrong. Page 715, I think is where it starts.
Did you kill
The reading is a little bit before that.
What's time you say? I'm guilty.
Brendan? I'm guilty. That's a funny joke.
Okay, I do have to warn you, number 1 is a blast from the past. It's a review of last year,
They rhyme.
scientific notation. If you get stuck, don't stay up all night doing it.
I
It's
forgot
fine.
time. Is it 8 times 10 to the 8?
It'll come back.
15 times 8.
The other problems are, let me see, there you go. 2, just A and C, you do not have to do 2B, or D or E. And then 4, 5, 6, and then 7A. 4 has multiple parts, 5 has multiple parts, 6 has multiple parts, and then just 7A. Solve simultaneous equations. That, you remember the substitution elimination thing? Remember the great Aunt Helga story? Did I tell you the great Aunt Helga story?
No.
I didn't tell you the great. Seriously?
No.
Oh,
What?
Tell us that.
I gotta tell you the great Aunt Helga story.
What's going on?
Okay, this is for people who are trying to solve 2 equations at the same time. It's a flashback from last year.
Like flash.
That's one of the reasons why I kind of irritated that the math is split over 2 years, because I don't get a chance to teach you this. I'm gonna do it, darn it.
Yeah, so you. She sees
Same here, 1, 3, 7. 2 times 3 is 6. And then you just got the sideways one over there. It's 19. 1 plus 9 minus 1 is 8.
There, go ahead and write this down. This will be the last problem of the day. There are more methods than this, but I want to talk about a method called substitution. It shows up a lot.
I know how to.
We're actually using it in calculus and pre-calc as we speak. So the question is, I want to find an x and a y that make both of these work at the same time. That's harder than getting one of these to work. If you just have one of these, you can probably guess and check a bunch of them. But how do you solve both?
I know. Actually, no.
All right. Here's a quick question as an intro. Everybody focusing on this? Suppose you have $20, okay? Would it be legal for me to substitute 2 $10 bills for your $20 bill? Yeah, perfectly legal. Would it be legal for me to substitute 2 $1 bills?
No.
No, that's called theft. I just stole $18 from you. It's a misdemeanor. I'd get jail time for that. So, questions? You can only substitute 2 things that are what?
Equal.
Equal, the same. Same value.
Both.
Now, here comes the weird story. Are you sure I didn't tell you this one about the Christmas?
Christmas?
I didn't.
love
I
this
apparently
story.
didn't. Shh. All right, start at the beginning. Suppose it's X number of years in the future. See what I did there?
13.
Variable. Okay. So you are. It's around Christmas time-ish, and you're planning to get a Christmas gift for. It was either your son or daughter or niece or nephew. Pick your favorite situation. So it's in the future, and
My pigeon.
they're 2 years old, and they figure you can. It's never too early to start them on their math career. So you go into one of those little super overpriced little catalogs where they sell knickknacks like glow-in-the-dark skulls and things for $49.
Oh,
It's, you know the things where they say it's, you know, here, have a
I
set
think
of
that's for Halloween.
slippers, you know, they're made of like fuzzy pumpkins or something like that. There are little itty bitty catalogs that sell a whole bunch of this stuff. They're like Neiman Marcus, and my mom has like 20 of these subscriptions. And it's like, who buys this? But you know, I don't know, whatever.
pumpkins.
Pencils that chirp when you whistle, so you can find them. It's
No,
just-
wait,
they're interesting, but they're also like $69. You know, anyway, you're flipping through one of these, and you say, aha, here's where the story comes back in. Listen.
I need more.
It says, here we go. Here's a perfect gift for my 2-year-old son, daughter, niece, nephew, fill in the blank. It says, it's a silver-plated Y. It's a variable. It says, what great way to get them started on their math career by getting this like silver-plated Y to play with, and they'll get used to variables, and they won't get scared of it when they go into algebra. Because the first thing people say is, what are all these letters doing in my math? So, get them used to it, and they'll think it's fun. So, you send in $49.95 plus shipping and handling, send it in, and then a certain number of weeks later, it shows up. The day before Christmas, the box arrives. And you say, oh boy, my silver-plated, my son or daughter or niece and nephew silver-plated Y. I need to take a look at it just to make sure everything is okay. So you open the box, and you take it out of the box, and you look at it, and you gasp. Because what you see is not a silver-plated Y.
Silver-plated X.
It is a silver-plated negative 2x plus 15. Somebody messed up at the company. Or
They have
did
those?
they?
What?
Quick question.
They are the same. They are.
Can somebody get Y by itself?
Yes.
How?
Subtract 2x.
Do it.
It would.
Put the negative
y
2x
equals
first.
Oh, yes,
Negative 2x,
substitution.
plus 5.
Sorry.
Yes, by the way.
15.
15. Now let me say that story problem again. You look at your silver-plated Y, but they didn't send you a silver-plated Y. They sent you a silver-plated negative 2x plus 15. Question, can you complain to the company?
No.
No. Why not?
Because Y equals.
They sent you what you ordered. They just sent it disassembled.
But you didn't want it like that.
Some assembly required.
I
So.
like this
But you
stuff.
actually have to have your son down to do the math, which is
Probably.
Not gonna
Unless you
happen.
do.
Wait, you could just do Z.
You know, you've gotten things that are disassembled that some assembly required, which are, those 3 words strike terror in the hearts of most parents. Like, I can't put this thing together, I'm doomed. Now, look up here. I told you that story to tell you this one.
Oh, another story.
Another story.
Now, suppose it was some years now or in the future, you discovered you have a long-lost great Aunt Helga.
Helga.
Great Aunt Helga is some relative she remembers seeing you last when you were 6 months old, and a lot has changed since then.
I wouldn't want to associate.
So Great Aunt Helga is coming to visit because she remembers how cute you were and wants to see. So here we go.
There you go.
Great Aunt Helga comes over and says, she comes to the door. Shh, listen to the story.
Okay, guys.
Space. Listen. Comes to the door and something to the effect of, hey, darling, it's so lovely to see you. It's okay, Great Aunt Helga, good to see you too. Oh, darling, shh, listen up. I have this lovely gift for you here. Open it, open it. And it's a big box. It's like 4 feet tall by 2 feet by 2 feet.
It's a monster.
And you're saying, okay, this is interesting. So you open the box. Now you gotta follow this, otherwise.
Your turn then.
Brendan, shh, pull the plug in the comments. Done. That's right. You open up the box and you find the ugliest vase you've ever seen in your life. It's got like ceramic animal heads hanging off the top.
Oh.
It's this putrid green color. And you're saying, gee, great Aunt Helga, that's really something. Oh, I'm glad you liked darling, goodbye. And you're sitting there thinking, what am I going to do with this thing? It's going to scare kids that they come and babysit. So, what do you do? Now, has anybody ever heard of the concept of re-gifting?
Yes.
It's like if you get something for Christmas or your birthday or something, it's like, I don't know what to do with this. And you give it to somebody else who you think might need it. Well, think of this. You get this big ceramic ugly animal head thingy, and you say, Cousin Wally would love a 6-inch, 4 foot tall. Yeah. So you say, Dear Cousin Wally, I saw this and I immediately thought of you. I also thought of the time that you shoved me into the swimming pool when I was 6. Yours truly, your cousin. P.S. Ha ha. And then you send it off to, Cousin Wally and everything is fine. Here's a question for you. Logic question. When you're re-gifting, who's the one person on earth you should not re-gift it to?
Oh, sorry.
Great, let's not expound. Great Aunt Helga, why?
Because then she would know that you don't want it.
Right, you don't re-gift it to somebody who gave it to you. You'd get something like, oh, you didn't like my gift. And then there's drama for the rest of the year. Watch carefully. What does this have to do with math? Ladies and gentlemen, we gotta get moving. You notice how you got y by itself? You found out that y is equal to negative 2x plus 15. Anytime you see a y, you can use this instead. Let's see what happens. Can somebody rewrite that top for me? Just using this instead of y. Go ahead. And by the way, whenever you plug in, always use parentheses. Go.
3x plus negative 2 parentheses negative 2x plus 15 parentheses equals 19.
Hold on, I can't write that fast. Equals 19. What can you do with that? Take over, Rob. What can you do with that?
Distribute the negative.
Distribute. Let's do it. So 3x plus what?
4x.
Positive 4x.
Plus 30. Negative 30.
Negative 30.
Equals 19.
Now what? Tress, take over. Right. What is that? 7x plus negative 30. Keep going. How do you get x by itself?
You add 30.
Okay. Good. What do you get so far? 7x equals 49. Keep going. So x equals what? 7. You got x. Mary, take over. What do you need to get yet? Y. How? Sure. This will give you the formula for y. By the way, you could plug them into either one of these. That'd be totally fine. This is one that's easier. Go ahead. Y equals negative 2 times what? 7 plus 15. Go for it.
Negative 14 plus 15.
Which is 1. Congratulations, you're done with the problem. You've got x, you've got y, and I guarantee you both of those would work. But let me show you something that would not work. Let me show you what would happen if you re-gifted it to Great Aunt Helga. Let me show you a tell. Where did you get the y from? Great Aunt Helga. Here's the Great Aunt Helga equation. Here's the Cousin Wally equation. In other words, if you plug this back into the same equation that you got it from, strange things happen. Watch this. What would happen? Because remember we plugged it into the other one? What if you plugged it into the same one? 2x plus negative 2x plus 15 equals 15. Let me do that for me. Something very interesting happens.
It's 0 because 0.
The 2x's cancel. I get 15 equals 15.
Yeah, whatever. Same thing.
Does anybody see have a problem with that? What were you trying to solve for?
X.
X. You notice what's no longer there?
E minus
X.
15.
The x died halfway through the problem. That's awkward.
Oh, that means you'll
If you're
die.
trying to find,
Hilda's gonna die.
it's kind of like saying, I'm gonna go pick up the car from the shop, and the shop no longer has your car. You're justified in being a little upset. If you're saying, I'm gonna solve for x, and then halfway through the problem, the x is gone. 15 equals 15. Yeah, I know. Where's my x? Do you know 15 is equal to 15? I don't know, I know, and I don't care. Where's my x? In other words, it doesn't work. Why do I bring that up? Well, take a look at problem. Where is it?
Okay,
Page 717. Problem number 7A. Now, it says solve the following pair of simultaneous equations. Wow. Look at 7A, the top equation. Have you seen what I'm indicating? Down. Do you see x over 3 plus y over 2 is equal to 9? That's a very strange equation. Is there a way to get rid of the fractions?
yes. You multiply it.
Multiply by something.
Oh, what's
Uh,
it?
One.
By something big enough to kill all the fractions.
10.
6. In this case, 6. Because they divided by 3 and divided by 2. So if you get rid of both of them, you're really multiplying by 6. Multiply the entire equation by 6. That'll get rid of the fractions. Can you tell me what to multiply the bottom one by to get rid of the fractions? 20. Correct.
20.
Multiply everything by 20. There is a method called elimination, which I showed you earlier in a previous story problem. That's one method of solving these things. This substitution is another method that requires you getting a letter by itself. But you choose whichever method you like. Again, don't stay up till 11 o'clock. By the way, don't stay up till 11 o'clock doing any of my homework. Unless you're just having too much fun, you can't stop, in which case knock yourself out. But if you're getting stuck and you're beating your head against the wall and it's getting late, go to bed. Bring the question to class. That's my philosophy. Brendan, quick question.
How do you use scientific notations again?
Scientific notation? I'll give you a 30-second crash course. $250,000. Big number or small? In your opinion?
25 times 10 to the third.
Kind of, sort of.
No, it's 2.5 times.
You've got to have the decimal right after the first place. So it's 2.5. Question is, here's the decimal right now, right? How many spaces do you have to move it over?
6. 5.
1,
Times
2,
10.
3, 4, 5. This is what's called the home position. The home position, if you want to be technical, is after the first non-zero digit. So it's after the first non-zero digit. And this is, would you call 250,000 big or small?
Oh, it's big.
Big. It's pretty big. So it's times 10 to the, there are 5 spaces here. Would you call this positive 5 or negative 5?
It's 80,000.
Negative. Positive.
Positive 5. Positive is for big numbers. Negative is for small numbers. So if I gave you 0.000719, first of all, big or small number?
Small.
Very small.
Small.
The home position is here, right after the first non-zero number. Not the first non-zero digit. How many spaces?
5.
1, 2, 3, 4, 5, correct. So what's the decimal part?
7.19.
7.19 times 10 to the what? If it's a small number, it's negative.
When did you drop something?
Make sense? That's scientific notation. So what you can do when you want to multiply or add or something like that, if you want to add those things together, turn them into regular numbers first.
Use it.
For scientific notation, tell you what, I'll give you one. You can go ahead and get started. If anybody wants a quick 1-minute demo on how to multiply these things, let me show you. 4 times 10 to the third times 6 6 times 10 to the 8th. That's kind of like a problem the book is giving you. Suggestions? I'm curious if it remembers the name of a property that says you can multiply in either order. Commutative property. Let me rewrite this. 4 times 10 to the 3rd times 6 times 10 to the 8th. Those are all multiplied. You can put them in any order you want. I'm going to do this. We had a chapter on this. What's 10 to the 3rd times 10 to the 8th? This is chapter 9. First chapter of the year.
I'm supposed to
Remember the
that.
rule? It's kind of like x to the 3rd times x to the 5th. How do you get that? You add the powers. Exact same thing. This is 10 to what? 11. What's this? 24 times 10 to the 11th. There's just one problem with this. You're almost done. Yeah.
It's 2.4
Ah.
times 10 to the 12.
Change this into scientific notation. Leave this alone. Let's scoot this over here. It's kind of a big number. It's 24. It's really 2.4 times 10 to the what? How many spaces do you have to move it to get it to home? I wanted a 2.4. One space. Do you think this is a positive one or negative one? I just want to change 20, positive one, because it's bigger. The smaller numbers will be decimals. And now, looky here. Combine these. What's the final answer? 2.4 times 10 to the what? 12. You got it. That's it. I'll leave that up on the board for people who want to study it. Rest of the hour is yours. You may work on this quietly. And Mr. Blau, working on math this one. Save the artwork for later. Not all of it. Show me. Everybody else, you may move the chairs if you put them back by the end of the hour. You got about 12 minutes, so figure from there. Double check. These need to be solved, perhaps. I'm gonna need to expect solve. Equation. Some of these. Oh wait a minute. Number 5 is good. Number 6 would be good. Oh, you didn't. Make sure you write x equals. Okay, that's it. You show your work too. That's very nice and concise, but on the test I want to see your work. Yeah. Sure.